that stayed the same are the gadgets that I use, because I use other gadgets such as tablets, phones, and laptops, and I tested all of those, and I think some of them, well, actually, they did all came out the same. They came out the same results, and I tested this 3 times to be sure my results were right.
This is our 3rd annual STEAM Expo. So right now we have our 5th and 6th graders being judged for their science fair projects. At 10:15 we have 3rd and 4th graders from the elementary coming to be judged for their science projects. We have over 200 projects going on right now between 5th and 6th grade. We have over 100 projects coming in after these guys get done.
So the engineering process is really focused around finding a problem and trying to solve that problem. So here we've got 5 stages of that process that they go through. So they're asking a question, trying to find out some problem to solve. They imagine some different ideas that might solve that problem. Then they plan, so they come up with a plan to figure out, okay, here's what we're going to do. Then they create that product or a prototype to try and design something, and so they're testing that product, that prototype or product, and then finally they're looking at what they did to see whether they can improve it or ways that they can improve it. So they just kind of repeat through that process a few times, so that, again, it's around that whole idea of, here's a problem, I'm going to design some product that solves that problem.
I really believe that IJ Holton is on the right track. We also, the school district, has really been promoting the whole concept of science awareness. Great need in our world today for better engineering processes, better scientific processes.
What's another thing that you could do to keep things fair? And you said you used the machine to kick it. What's another, would you use the same surface for each of these in the same place? Where did you end up using the ball kicking machine?
Outside. Like on the cement.
On the cement? Okay. Same cement for each one? Okay.
Students, or children, start questioning at an early age, and so we try to foster that with their science projects, to start with a question, just that curiosity, get them thinking, and then the scientific method is just a structure of how they can find out the answer to that question. And so it gets students thinking about the world around them, and not just the simple things, but maybe the big picture of how they fit in the whole realm of what's going on in the world.
Yeah, that engineering process, I mean, it really applies to all kinds of things. It's because at its core, it's that problem-solving thinking, which is the key thing that we're trying to teach through that process. So if you're looking at a math problem, you can really go through that same process of figuring out, okay, what's the problem? All right, I'm gonna come up with a plan to try and solve it. I'm gonna test it out, see if it works or not, find out if there's ways to improve. So it really applies to all areas of life and academics.
There's a lot of potential in these young minds here, and I love it when I see the school getting behind expanding their interests in so many of these things. It'll make education a lot easier if they know what their eventual education is leaning towards, rather than just memorizing dull facts. If they know that there's a purpose behind the things that they're learning, it makes learning so much more interesting and enjoyable. So I'm all for that.
So it's an exciting day. We're excited to have the kids all involved. The staff and students have been working on this for a few months now.
The kids have put in a ton of work for this today. It's really exciting to see the work that they're doing.
You're doing a great job here. And I'm just one of about 2 or 3 dozen judges today, so there's a lot of interest within the community.